I think this was the chapter we stopped yesterday. The while statement, the increment and decrement, for statement, nested loop, and which other one? Yeah. So if you had time to review yesterday, what we taught, by now you have a better grasp of what the knowledge we were trying to pass here. So today we said we are going to focus on let me see, on objects generally, mutable, immutable object, and then designing classes. However, we are also supposed to do things in the aspect of OOP, like extended classes and all of that. But it looks like we will not get to this part today, and we will focus more on it by the time we start building our page objects with Selenium. So let's just focus on 9, 10, and 11. Immutable objects, mutable objects, designing classes. All right. So when you are talking about objects, virtually we have seen objects so far. We might not have known that they are objects for some of the classes that we have been creating. An example of an object that we have not considered as object is the scanner class. If you remember the scanner class in, is it chapter 3, you see there's something called the system class called what? Scanner. Now, this scanner, when it is initialized, you discover that it is initialized like this, right? Scanner in equals to new scanner system.in. In here can be any object. You can decide to call it scanner, scanner SN, scanner whatever. Now, initializing it here and using it in every other method makes it a what? An object. Now, talking about object, it is the way, let's see, let's go back. Now, it is the way you perceive data. In here they call it a collection of data that provides a set of methods, right? Of course, it will always provide a set of methods. That is what makes it an object. It provides a set of methods. So it becomes what? It becomes an object. It's no longer a variable, or it's no longer what will I call it now? An instance variable. Now it is what? An object. Now, to also clear your confusion for some of us that are starters here, sometimes when you hear object, you are scared. You're like, okay, object, which one is object again? So I mentioned the example of scanner class, right? Now, another one is you need to understand data types and how it works, right? For example, talking about strings. Can someone hear me? It's like someone's mic is needs to be muted. Right. So don't let me skip. I wanted to skip before. So when you talk about primitives, we're talking about primitive data types like int, double, char, and boolean. Those are primitive data types. And when you're using them, and you are in, for example, the first line you see here is what? Is an integer. An integer number that is assigned a value -2, right? This is what? A primitive to a primitive variable, right? It is not an object. It is what? A primitive variable. Well, I talked about indexes yesterday too. Now, if you look at this now, look at this character. We've not talked about array. Okay, we jumped array, right? Let's see. Let's see where array is. Array is here. Let's say something about array before we move on to objects, to mutable and immutable objects. So let's talk about array. So creating of array is a sequence of values. When you want to declare, let me mute that person. So when you want to declare an array, how do you declare it? You say the data type and your square bracket, then the array name. How is it different from when you are declaring variables? Look at the difference is this square bracket, right? Isn't it? So this is what array declaration. Now you want to give your array a name and then um give it its values. To create an array itself, you have to use new operator, which you first saw in, okay, the new operator allocates memory for the array and automatically initializes all of its elements to 0. So what we are trying to say is, for the array to be created in the memory space, you have to use the keyword new. All right, you have to use the keyword new. By declaring it is not enough. Yeah, you're declaring that you have an array int count, but for it to be created in the memory space, you have to use what new int, then whatever the index of the array is. So this is saying uh we have index from 0 to 4 in the array memory count in the memory of the computer. For count, all right, we have 4 elements there. That is an array, and they are all integers. And as for this one, it is also saying that it's saying the same thing. However, this is just a different data type. This is double. So this is how you do what? This is how you create your array. All right. There is another way you can create it, and it is also like this. All right. So creating an array A here, and then you immediately mention the elements within the array. 1, 2, 3, 4, 5. I mean 1, 2, 3, 4 is in array A, which is what? Element of what? An integer, right? Array A has integer elements 1 to 4. That's what it means here. That is what this means here. All right. So this is how you do what you create an array, and here you do what you declare an array. But here you have done what you have successfully created an array. You successfully created an array, and here you have also created an array. However, you have the elements clearly written here. All right, so how do you now access array? Let's create let's see. Let me call this one array. Okay. So I'm calling this one array. And then look at this. How do you access the element of an array? We have count already, Abby. So what is our count? Our count is supposed to have what? 4 elements within the memory space. So we have count here, and it's 4 elements. 1, 2, 3, 4. Right? 4 elements. However, we talked about index yesterday. The first element carries index 0, second one carries index 1, third carries index 2, and the fourth one carries index 3. That is how you access the array. So if I say I want to access the element in this third space, then I will say count square bracket 2, right? Count square bracket 2, just like this. Yeah. So if I want to access the element in the first element, what will I call it? I'll just say count square bracket 0. If it is the second one I want, it will be what? Square bracket 1. And if it is this one I want, square bracket 2, and then square bracket 3. So that is how you access the element of an array. All right, let's do something here. We have this is not going to fly. Let's just write our what's the name now? Our main method. Public static. Mm-hmm. Void main. Okay, so we have something like this. Mm, we have, so we want to declare this A. Am I clicking on? And so, like I said, you need your square bracket and then the name of the array. So you can say A equals to what? You can call new array, that is one way, right? New, using the keyword new, and then you say you have 5 elements or 4 elements or so. Then you can also say int A equals, yeah, nice suggestion. You can also say int A equals to 1, comma 2, comma 3, comma 4, comma 5, right? So now you have created an array A. Okay. All right. So now that we have this, so you want to access the element of, we have, let's see, I can say system.how.print. Oh, so just to access system.how.print. What do I want to access now? 012. I want to access this one here. So that will be 01012, right? 2. Okay. So I will save the third access the third element. Okay, access the third element. Access access the third element. Okay, so let's execute this and see what we have. So the third element is what? 3. You see now. So what I'm trying to do is I'm trying to access the third element here. The third element here is 3, right? It's not the value, it is the element. Now I can decide that my third element is 8 here. Okay, so now look at it very well. Index 0, index 1, index 2. So I want to access the value that is within index 2, right? So I can also say I want to access 3. So if I say, okay, so let's do this 2 again, since I've changed the value of the um of the second index in the third position. All right, this should print 8 because it is the index, okay, that we are trying to access. We're trying to access the element through its index. Yeah, I think that is the right word. We're trying to access this element through is what? Its index. So at the end of the day, we have 8 here because the value of its index is what? Is 2, right? And if you want to access the last element, what would that be? That would be the last element, 5 minus 1, which is 4. This should be 4. By the time you execute it, 5 will be printed. And so you see that's the last element, and that's what you have right there. All right. So we said that okay, that's what all of this is trying to say. Okay, let's look at this. You can use this operator anywhere in an expression. This is trying to say we are assessing the index of the array count. This count here is an array already that was already created here, if you recall. So we have count index 1, index 2. So this index 2, what do you think the increment plus plus is saying? We talked about increment and the decrement yesterday, if you recall, right? So increment means what? Add 1, right? It means add 1. So we are trying to say the value within index 2, add 1 to it, and then you have it. And here we will say subtract 60 from the value within index 3. All right. So that's what you have. We talked about the minus equal, the plus equal, the plus plus, and the minus minus yesterday, if you recall. All right. Here again we have a while loop and a for loop, and except that this time around we are dealing with arrays. All right. Let's look at this while loop. This while loop says the initial value of I is 0. And then we have a condition saying that 0 is less than 4, which is true. So since this condition is true, what happens? We'll print out what? The first index, which is what? 0. And if you print out 0, is 0 less than 4? Yes. So add 1. When you add 1 to 0, what happens? You have 1. Is 1 less than 4? Hmm? Yes. Add 2. Is 2 less than 4? I mean, yeah, add 1 to 1 becomes 2. Is 2 less than 4? Yes. Add 1 to to 2 and to become 3 is 3 less than 4, and so on. The same way we discussed, the same way we checked the conditions yesterday, it will keep looping until we have a condition that is false. That is when it will stop. All right, so this while loop counts up to from 0 to 4. When I is 4, the condition fails and the loop terminates. So the body of the loop is executed only when I is 0, 1, 2, 2 or 3. In this context, the variable I is short for what? Index. So let's look at one of these examples. So we have okay, we have talked about this one is array. We can just comment it out and use the same main method. Except that we have not created a count here. So let's create count. So we say int count. Good. Int count is new int 4. Now that we have our array count, so we say for I, when I start from 0, right? When I as this I is index, by the way. So we have index from 0, and then index less than 4, index plus plus. This is the condition. Print what? Index. So how do you get this index? So you will say that I is what? 0, right? So is 0 less than 4? Yes. All right. So what will happen? You will print what? 0 first, right? So you have 0. Come on. Now, when you had 1 to reach. Remember, we said this is our step yesterday. This is our condition, and what? This is our what? The initial value for our I. All right. Now you have 0, right? Add 1 to 0 for this condition. What happens? You have 1. Check the condition. 1 is 1 less than 4. Yes. Once this is true, then print what? Print 1. And then what happens? You go back and check, and then you add 1 to 1. What happens? 1 to 1 is what? 2. It's 2 less than 4. It's 2 less than 4, true. Then what happens? You print 2. Okay. And then you check again. By the way, that's 2. Then you check again. You had two. I mean, you had 1 to 2. It makes 3. And then you check, is 3 less than 4? Yes. Right? Then print what? 3. 3. And then you had 1 to 3. It's 4. Is 4 less than 4? No. Is 4 less than 4? No. That means you cannot print 4. It therefore stops here. Right? Now that is what this this is what this loop is doing here. For the count array, the unilegal indexes are 0, 1, 2, and 3. If the index is negative or greater than 3, the result is an index out of bound exception. You will have an exception there if you have something more than 4, because the condition always have to be true. You always have to check the condition. The condition is false, you have to stop the loop. All right, so that is how you create an array and access elements in an array. I think that is just the basis of what you need as we progress to immutable objects. Now, about objects. Talking about objects, all right. So I've explained earlier about objects, but talking about immutability. How do you say strings are immutable? We usually say strings are immutable. Why? It's just the same interpretation you give. What will I call it? The English grammar says immutable means something, mutable means something. It is the same in coding here. What does let somebody answer? What does immutable mean in English? In the English grammar? What does immutable means in the English grammar? Someone, please. Anyone? Immutable. Hmm?
I think it means something that cannot be changed.
Never change. Good. And mutable is the opposite of it. That means that it can always change, right? Great, thank you. So when you say strings are immutable, it means it cannot change. Now look at this. We have a string name, a string called name, and then we have it called Alantuni. Of course, when you are talking about string, you don't forget that this has to always be there. It makes it string. So we have string name Alantuni. And then we have string upper name equals to name dot uppercase. Now you assume that the name here that is being called is also the name here, right? So we have a name here already. Now we are now trying to say this name, that is Alantuni, convert this Alantuni to do what? To uppercase, such that all of the characters here are what? Are in capital letter. So in the memory of the system, it's going to read string name as Alantoni. And when it wants to convert it to uppercase, it's not going to see it as the same. It's going to create it as different. It's going to see the uppercase Alantoni as a different string. All right, so let's look at it. After this statement run, upper name refers to the string Alantuni, yes, because it is to the uppercase now, but name still refers to Alantuni. A common mistake is to assume that uppercase somehow affects the original, so it does not affect it. So this is the number one reason we say strings are immutable, because somehow whatever you have declared as the initial value of a string remains its value, even when you call other methods on it, like change to uppercase, like some other things that you call on it, replace and all of that. It will still see its original assignment, original name, right? String name is still Alantoni despite the conversion to uppercase, or despite the replace or whatever that is being called on that string. All right. We said a similar method is replaced, which finds and replaces the instance of one string within another. This example replaces computer science with CS. As with uppercase, assigning the return value to text is important. If you don't assign the return value, invoking the string are immutable by design because it simplifies passing them as parameters and return value. And since the content of a string can never change, let's come again. And since the content of a string can never change, two variables can reference the same string, right? Without one accidentally corrupting the other. This is where you see the immutability of strings in Java. All right. That is all the explanation about immutable. I will not say much about this. Let's go to mutable objects. Now, immutable objects, what are the examples of mutable objects? We have a whole lot of them, and we will consider them one after the other. Now, look at this memory diagram. Memory diagram showing a variable that refers to a point object. Okay, so what is our point? All right. Now, did we talk about creating packages? Yes, I think we talked about it from day one. So, how do you create a package? We said a package. I don't know if it is this class. Okay, let's just come again. If it is not this class, a package is a collection of classes, right? It is a collection of classes. So, if you want to create a package, like I created Java lessons, this Java lesson is a package, of course. Now, if you want to create a package, you just need to do new create package. All right, and then the package will be created. And every time you create a class within a package, you will see something like this. Let's assume I want to create object, a class object. You see this class I've created within this package, Java lesson. You see it is carrying its name here. Look at it. This is the first package I created. All right, the initial. I created com.qafit automation classes. Selenium lessons. And then this is the other package I created under it, Java lessons. So the moment you create other classes within this package, what happens? It automatically carry the package name, right? It will automatically reference the package name. And that is what comes first. Now, after this is your imports. All right. This import has to do with your Java libraries. An example of Java library that we see today is what? Java.awt.point. Another example is the scanner class that, I don't know if it was this class. We looked at scanner class. Have we looked at scanner class in this class? I think we did. Variables. Talk about scanner class. Yeah. Okay. Maybe not control object. Okay, I just created this one. Okay, maybe not in this class. Variables. Okay, maybe not in this class. Okay, let's talk about the scanner class. Now, I'm already in object, right? And I want to import, let's see. This is chapter 10. Okay. Now, this scanner class, we have something called java.util.scanner. Java.util.scanner. Now, the moment it downloaded your Java JDK, Open JDK, whatever, you already have your Java libraries automatically downloaded for that version on your system. So in order for you to access these libraries, you have to import them. So we have import java.util. What this means, this statement means that we are importing a class called scanner from the library called util within the Java libraries. All right. So we want to access the scanner class within the hotel library. All right, so that is what it means. So you want to import and you want to make use of scanner. This is how you do it. You put this import, but it is going to look like it is faded, just like it is faded right now. Why? Because you have not made use of this import, right? The moment you start making use of the import and you maybe say let's say scanner equals to new scanner.in, right? You see that this is no longer looking faint. Now it is like it is being used, although there is still a faint object here, right? But the moment you start accessing this scanner in other methods, it becomes what? It becomes usable. For example, you can create a main method here and say yes, publish static void main. Create a main method here and say um scanner and say something like scanner. Of course, I have to declare it again. Okay, let's do it again. No, I can just say scanner dot next int, scanner dot next line or something. Or let's do it like this: system dot out the print line. What input a value, input a value. Then I will now say scanner. Let's bring this into our main method. So we have something like this. The moment I make use of this scanner object within a method, you see that it is no longer faded, right? It's now become like bold and all of that. So we have used it. So what does scanner itself do? It allows user to interact with the system, right? Look at this example that I have just done. I say input a value, and you see that I actually input a value. I mean, actually display input a value where I can put something, right? So that is exactly how it allows user to interact. So we have the scanner, and that is how import works. Going back to where we are coming from I think we are coming from this mutable object. We are talking about yeah, Java libraries. Import java.awt.point, right? So java.awt is a package. The Java AWT package provides a class named point. So there is something called the AWT package within the Java library that provides a class called what? Point. Now, point is this what will I call it now? This class that helps to define your x and y axis, something in mathematics. So don't let us look into that one. There's something else I want us to look into. Here, yeah, this one here. Object as return values. An example. All right. Look at this example here. This is also still mathematical. As most of my students say, it is mathematics we are doing in class. The last class I took. Let's just look for something much relatable. Java library source. Oh, yeah. I know we should have an example. Okay, now let's look at this example here. We have a class called surprise and a main method, and we have a string called imom. That's a string s1, and then we have another string called s2. So we have this s2 being concatenated with what? I mean, this string here being concatenated with another string. You should know that this I mom is as if it is the same as this other one, because by the time you output this also to the console, you should get something like I mom, right? Because that's the set of concatenation, right? So if x1 is equal to, we talk about equal to, like exactly equal to s2, that is, if this string s1 is equal to s2, then print s1 and s2 are the same. If I should ask you, are they the same? Look at it very well. Is s1 and s2 the same? Anyone?
Yes, they're the same.
They are the same. Any contrary opinion?
Yes.
All right. So let's see if this is true. If the statement is true, then we should have this what? This statement being printed to the console. So let's see.
They're the same. It's just that I think the appropriate way to print it out is that S.
See what?
I said I think they're the same, but I think the appropriate way to print it out is the S2.
It's the S2. Okay.
Yes.
Okay. That is fine. You can print it out there like this. You can also print it out like this. So what we are trying to say is it's possible to have one string to be equal to the other string, right? Let's look at the what the display the textbook is saying. As a result, the test s1 equals to s2 turns out to be true, which means that s1 and s2 refers to the same object. In other words, they are not just equivalent, they are identical. Although immutable objects have some advantage, mutable objects have other advantage. Sometimes it is more efficient to modify an existing object rather than. So what we are trying to say is, the other time we talk about objects that are what immutable, that they cannot change, right? And now we are talking about objects that can what? That can change. And we are saying that this string here, this is supposed to be a string. And we already said string are what? Immutable. If you don't if you recall, we said they are immutable. Even when you try to call other methods on those strings to change their value, they will still not change, right? They are immutable. But we are also talking about objects that are mutable in this chapter. There are objects that are mutable, that is they change over time. They if you call them in some other methods, they can change their value, right? An example is the one that they were trying to explain earlier about the points class in mathematics. The this one I didn't go straight into the point class. Okay, the point class. Okay, so we are saying the point class is mutable because the values, look at it, let's just look at this. We have point p1 equals to new point 0 comma 0, point p2 equals to new point 3 comma 4, double distance equals to p1, that is 0 comma 0 dot distance of what? P2. Now distance is 5. What kind of calculation was done here? They are trying to calculate the distance between point P1 and P2, right? If you draw that one on a line scale and all of that, you can find the what's the name? The distance in mathematics as 5, right? It turns out that you don't need print point method. Okay, don't let us go into this. I need a better example. This book is not giving me a better example. It's not giving me a better example. It's not giving me a better example. Maybe we will still see more example in the next chapter. I hope. Um, because it seems we have come to the end of this chapter. Okay, yeah, we can just look at our exercises. Hopefully, we can get better examples here. Look at this exercise 1. For the following program, draw a stack diagram showing the local variables and points of main and whatever redo returns. Okay, so we have a main method and we have another method called redo. So what is the output of the program? Okay, so we already I explained how code execution flow, how it works. That you check your main method first, and then you execute that before moving to other methods. Now in this main method we have int x equals to 5, and look at this, point blank equals to new point. What do you think they are trying to do in this line? Look at the keyword new. Look at the keyword new, right? And you already know that point is what? Point is a Java class, right? So it's already a Java class. Is it not? Yeah, it is. So we are we are instantiating a blank object so that we can use this blank object in our methods, in every other methods. Now we have it as 1, 2, that is x, y. 1 represents x, 2 represents what? Y. And remember, we have an initial value of x as 5. So if you want to do this, you say system.out.println redo. What is redo? It is going to go back to this redo here. This redo is what? Is an integer return type that takes in what? 2 parameters, integer x and point p. It takes an integer x and point p, and then x here that we are trying to print represent integer x here, and this blank does what? Represents point y. Okay, now how is it going to attack this method here? Look at it. We have x equals to x plus 7, and what is our x? Assumably our x here is 5, so we have 5 plus 7 to give us what? 12. So if you want to print this out, it's going to print this as what? 12. And what is blank? This blank is representing point P, right? Now, this blank in itself is this one here, right? And so you want to print point P. Okay, so point P takes in, normally because it is point, it should be in 2 dimensions, x, y, right? So we have a new value 1, 2 for blank. So at the end of the day, point P is what? 1, 2, right? So this is 1, 2. That is what is going to print for blank, 1, 2, and then 12. But don't forget, there is still a return here. The return saying that x plus p dot x plus p dot y, right? Now this x here, we assume that this x here is the same x as 5 plus p dot x, which is p dot p. This p is point, right? Which is 1, 2. So we have 1 dot 1, 2 into what? 5, Abby, plus 1, 2 into what is y? Into 2 into this is confusing. Okay, now I'm confused at that point. Let me stop there. Let's continue with this. This return is confusing, but we have to put that into consideration. Okay, so it is going to print out this first and then move on to this. system.out.print x. You already know the value of x is 5. And then it will be system.out.print blank dot x, which is what points, that's 1, 2 dot x, which x is also 5. And then system.out.print blank dot y, which is what 1, 2 dot. Now this y here is as confusing as this y here. It's going to be 2 because we have only one y, and that y is what is blank, and that y is blank. So of everything mentioned here, there is only one y that exists, and it is this y here. All right, so this is what, let's see how this plays out on IntelliJ. I really want to see. Let's see. Let's see how this plays out. Where should I put this? Okay, I can put it here too. Okay. This one has its own main method. I'm going to remove it. Okay, remember I have to import java.jwt, which is java.jwt dot, let's make it point. Since it is point they use in this example, point. Okay, so we have that. Oh, redo. We need to copy redo out too. What have the redo method? The redo method is here. So we have, let's put the redo method here. Okay, now that settles that. Now that we have the main method, we have our x equals to 5, the instantiation point as blank, and then a new method called this. Let's see what this output will be. Bingo. Okay, great. Now let's look at it one after the other. The first one says system.out.println redo x, comma blank. That is redo. This one we said is x5 plus 7 is what? 5 plus 7 is 12, right? But that is not all. We also have x plus p dot x plus p dot y, right? So the x is 1 and the y is 2. So we have 1 plus 2 to have 3 plus this to have, okay, very clear. So this x here we got here was 12, right? Was 12. By the time you get here, you now have something like 12 plus 1 plus 2, right? 12 plus 1 plus 2, which is what? 15. So that's the first thing that I get to print out. Interesting. So it also means that this is what? 5 plus 7. Right? So that one is clear. That's for the first print statement here. Now the second print statement says print x, which is what? 5. Okay, so I think this one is clear. Now the third one says print blank dot x, right? Which is 1, right? So we have 1. And what is the last one saying? I get it's the dot that was confusing, but it's clear. Yeah, y is 2. I said it's only one value of y we have, and it is 2. Okay, so now I think we have a very good output. But what is the question here? What is the output of this program? Is the blank object mutable or immutable? How can you tell? So they are asking if this blank object is immutable. Let's look at this again. Okay, so we have the very first time the blank was instantiated, x value originally is what? 1, and then y is what? 2. However, for x, there is a value for x before now, which is what? 5. So what can somebody tell me about the blank object? So when we have blank here, and blank here has always taken it has always taken the value x and y as 1 and 2, because if you come here you discover that x is still 1 and then it's still 2. So tell me, is blank mutable or immutable? This one is very clear. Is it mutable or immutable? The blank object. Don't go and check textbook. Oh.
Immutable.
It's what?
Immutable.
Okay,
It
is
doesn't
that
change.
correct?
Value doesn't change.
Are you sure? Are you sure? Anybody that wants to dispute that? Nobody's saying anything.
Immutable now, it doesn't change since they told us that is x, they declared it already to say x is 1 and y is 2. And that's the value throughout the code, as well, like call it, throughout the program. So everywhere we see blank dot x is 1, we take it as 1. And anywhere we see blank dot y is 2. So I think it's immutable. I'm not disputing what you said there.
Hey, I want your response. Response with explanation. After that, we will move to Philip. We'll call everyone today. Okay. Now tell me. Is Jumai in class? Okay, if Jumai is not there, Philip, please go ahead. Explain this. Is the blank object mutable or immutable? How can you tell?
See?
Hmm?
Sorry, I'm still looking at it.
Okay.
Can you go back to the...
The textbook.
Yep.
Okay.
I think it's mutable.
And why?
I think it's mutable.
Why do you say so?
Because but I think it has I really can't explain, but I think it's mutable. Can't just figure out how, why it's mutable.
Any other person that wants to prove have a contrary answer or the same answer as Philip? All right. So the answer is that this object is mutable. We find this at the beginning of this textbook here. You might not have gone through the examples they gave because of its mathematical nature, but we talk about the point object as mutable. And the point object is what? Is blank. Yeah, if though we gave it a terrible name, I don't know why they gave this name as blank. Look at it. This is points. This is a Java library class, right? So for us to even use it, we have to import it here. We have to say import java.awt.point, right? So that was how we are able to what to use this point here. So assuming they even call these points like small letter points, maybe it will have been clearer instead of them using a very terrible name called blank. So this blank object here, right, has values 1 and 2 as x and y. However, let's see what this textbook said at the beginning of this class so that we have a clear picture of what we are trying to say here. So we say in maths, 2D points are often written in parentheses with a comma separating the coordinators. For example, 0, 0 indicates the origin x, y. Indicates the origin, and x, y indicate the point x unit and y as what? The y unit. So Java.awt package provides a class called points that represent the location in a Cartesian plane, blah blah blah. And when they were explaining it, they gave a lot of mathematical examples. So we say import java.awt.point. Then to create new point, what do you use? You use point, whatever. They gave it blank here too. Point blank goes to new point x, y, which is what? 3, 4. The first line declares that blank has type point, yes, and the second line creates the new points with the coordinates x and y as 3 and 4. The result of the new operator is a reference to the object. So we have a reference to object blank that says that our x is 3 and our y is 4, right? This is the memory diagram, but the explanation continues. As usual, the name of the variable blank appears outside of the box and its value appears inside the box. In this case, the value is a reference which is represented with an arrow. The arrow points to the point object which contains two variables, x and y. Variables that belong to an object are called attributes. In some documentations, you also see them called fields. To access an attribute of an object, you use a dot notation. So because we want to access the value of x here, we say blank, which is anyway when we move to other very simple examples. I think this example in this textbook is annoying. So we have something called blank, which is an object, but we want to access the attributes of it called x. Is that one of its attributes is x, so we now say blank dot x. The expression blank dot x means to go to object blank and then get the value of the attribute x. In this case, we assign that value to a local variable named x. There is no conflict between the local variable x and the attribute x. The purpose of dot notation is to identify which variable you are referring to unambiguously. You can also use dot notation as part of the expression blah 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 blah. They have not explained this.
Please, they wrote
Not
mutable versus immutable down.
Tony said something.
Yes, there's a part where they put mutable versus immutable. It's still
Okay, let's
down
check it.
the page. Yeah.
Let's check that part. Okay, let's check this part because they are not giving clear explanation. So we have something called mutable versus immutable. Because the attributes can be modified, you can rectangles are mutable objects because their attributes can be modified. So you can modify their attributes directly. So when they say rectangle, it means we are referring to the point object we are talking about, since things that have attributes X and Y. The reason they are mutable is because you can modify their attribute directly, like box.x equals to 15, or you can invoke the method that modify their attribute, like box.translate, blah blah blah. In contrast to immutable, so let's see where this thing changed. Let me just explain. I don't like all this the explanation. Now, where it changes this, look at this redo, for example. Redo takes in int x comma point p. Now, int x is clear. We have a value for it from the beginning, which is what, 5. But point p, right? Point p is going to be picked from here, right? Now, this point a p here is supposed to pick its value from blank, right? Now, there is an expression that says x equals to x plus 7. That is, the new value we want for x, we will take an initial value of x and add 7 to it. Then we will get a new value for x. And that is how we got a new value for x, which is what? 12. And then on getting the new value of x, we use that new value, right? That is 12. And then we now got the attribute of p. And what is the attribute of p for x? It is 1 here. And then we got another attribute for y, which is what? Which is 2. At the end of the day, what do we have? At the end of the day, we have 12 plus 1 and 2, which is what? 15. Now, this in itself, right, is 15. So we have, normally we should have, for this first print line, we should have 5, comma, hold on. Yeah, this should be 5. Okay, we have used the 5, don't worry. And then this should be blank, which is 1 and 2. 1 and 2. So we still use 1 and 2. It did not change. It did not change. Did it? No, it did not change. But however, because we are using points, right, it is expected that the values of points can change at any time, because you can call them. I'm still looking at this. I think it is from here that x changed, because if you, whatever you return here becomes the new value for x. The first value was 5, and then we had 12, and then now we have 15. But you can't exactly say that that is the value. Okay, I think it is 12. This is how it changed. But this value here is not point, so I can't say it is. Okay. It did not change. It did not change. So we have print x, which is normal x, and then we call the value of x on blank, which is 1, and then we call 2. So it did not change. However, normally it is expected that this object should be mutable. But in this example, I guess the guys that said that it was immutable were right.
Yeah, pizza for us, please.
Okay. It did not change in that example, but all the same, generally, you should know that. You should know that the point class changes. All right. It's because we didn't have very good examples right from the beginning. But I think we will still get better examples. Let's see. We should still be able to get better examples in
Okay, so sorry,
Mutable.
I just wanted to say something. So because I think the confusion would have come for where we add integer x initially. Maybe if we had declared integer to be another letter, or these are our
Okay.
points where some other, yes, this integer x, this int
Mm,
x, we had declared it to be 5. So when
mm,
we now have our point x and y again,
mm.
maybe if it was point s and something, I'm just saying, maybe it would have been clearer. But I just knew that the x of 5 is different from x of 1.
Fine.
So
Yes.
Yes, and so definitely it did not change, even while we were now adding it to this p.x and the p.y. So it was just like an addition, not that the value changed in itself.
Yes,
And
yes,
that was why I
yes.
formed
It,
my
it
own
did not.
answer.
It
Yeah.
did not change. It did not change. It did not change. Right. You were right. You were right. Okay, good, good. It means we are understanding all of this, even though we didn't have good examples to explain this. But I think we have better examples as we progress. There should be, let me see, there should be exercises that can show this more. There should be exercises. Aha. What's this one say? It's like it's another mathematics. Everything is mathematics anyway, so we can't escape this one. The point of this exercise is to make sure you understand the mechanism of returning new objects from methods. So the following code uses find center and distance as defined in this chapter. Draw a stack diagram showing the state of a program just before this find center. Where's the find center? Returns. Find center returns. Okay, find center. This is find center. Okay. Point center equals to find center rectangle. Returns. This is supposed to be a method somewhere. It's supposed to be a find center method. Um, and there is supposed to be first, what is the output of this program? Can you tell without running it? Can I tell? Okay, let's see. Without running this, let's read this code. We have a main method called okay, main method, and we have point blank equals to new point x comma y 5,8. Now we have something being instantiated here, an object rectangle and an object center. Now, okay, an object rectangle takes in 4 sides. That's x whatever sides. That's the 4 sides of a rectangle now. 0, 2, 4, 4. Okay. And then we have something called point center, just like point center equals to find center. Find center is supposed to be a method somewhere. That is still what I don't know. Okay, so find center takes in a rectangle, and this rectangle is what is this one. Now, double distance equals to distance center, comma, that is this one, comma, comma blank, which is 5,8. System out of print line distance. So we are saying print distance. What will distance be? Distance will be center, comma blank, which is rectangle, comma, that's 5,8, right? Which is rectangle. And what is rectangle? Rectangle is this. So it's going to be 0, 2, 3, 4, 5, 5, 8. That is what is going to print as distance. But I think it's going to be in form of a formula. What is the formula for the distance anyway? So that's what is going to calculate here. But however, you get the gist. The gist is that you look at what is supposed to print out, which is distance, and this distance here says center and blank. And what is center and blank? You come here and you find your center, which is what? Rectangle. And what is rectangle? Rectangle is what? This. Okay. And then what is blank? Blank is what? This. So yeah, this is the flow of execution for that program. Okay. Interesting. Interesting. I don't know if I should give us example assignment for this. Yes, assignments, exercise 2 and 3. Let's juggle. juggle your memory a little. Exercise 2 and 3. Before I move into something more interesting, this part is a little bit. Let's move into something interesting for the next 10-15 minutes. We'll be done with that very interesting part. We call it designing classes. All right. We call it designing classes. So by now you have come across what we call class name. So you have been seeing class name, public class, whatever you call it, a class name. So this is a class name for this particular class here. So, and you've also seen the class that comes from the Java library itself. So what exactly is class, right? So we have, like I explained earlier, your package is a collection of what your classes, and your classes is a collection of methods. For example, this class has main method. It can also have other methods like redo, right? It's a collection of methods, and every method is a collection of what, of block of code, or will I call it um objects, collection of objects. All right. Now let's see. So again, define a class, create a new object type with the same name. Class definition is a template for objects. Every object belongs to an object type. A new operator instantiates object, and whatever. These are just key things to note. You will be frequently you come across this frequently, and you need to understand what it means. Every object belongs to an object type. That is, it is an instance of an object, or be of a class. An instance of a class. So you say an object is an instance of a class. What does that mean? It means that it's when you say an object is an instance of a class, it means it has attributes, and these attributes can easily be accessible even within its class. So that's what it means. So for example, we were given an example here called time. So you call this class time. However, when you are defining time, it's like your definition is public class time. It's like this particular block of code is saying, I want to define time. What is time? In English, we say time is a period, or it is history, or we say time is money, or you say, no, it has different definitions, right? Depending on whichever way you are looking at it. But in code here, we want to define time. How do you define time? You say, okay, time has hour, it has minutes, it has seconds, it has dates, it has calendar period, it has time zone, it has, those are the attributes of time. So here you are no longer seeing time as class, you are also seeing it as objects, all right? Because it has a lot of attributes which you want to define within it. All right. This gradually takes us to OOP anyway, which we will see by the time we move into Selenium. So we have the type class. Here is public. Now we call these access modifiers. Public, private. Wherever you see public, private, the access modifier. What they mean is you can access this class publicly outside of this class. It is public because it is accessible outside of this class. It can be accessed in another class. It's like saying I want to access class, like say I want to access class objects within class control. I have a class control here, and I want to access class objects here. So I can maybe go to my main method and say, class object, oh, I want to access you. So I will say objects here. I can call it this way. So I will now, for me to now access the attribute that I want to access inside object, I will call it a name. So I will say this is my class object that I want to access, right? I will use this new keyword to instantiate it, as you have been coming across new for a while now. So when you see the new keyword, you are instantiating an object. So I want to be able to access object within control class. Just look at it. Because class object is public now, it is public, it's not private. I should be able to do what? Access it. So I have object equals to new object. Okay. So I can now say obj, right, dot whatever attribute I want to access within this object. What do we have here? We have redo. I don't know. Let's see if I can access redo method. So I can say obj dot redo dot, there is nothing else. Why? Because redo is not something I can easily access. Let me go back to object. Is that it? Okay, let's see. Let's see if there is something else. Because once you put your dot here, you must be able to, you will see all the various attributes of the object you want to access. Good. There is nothing else I can access. Anyway, this is how you try to access classes and method within other classes and method. Now, private int hour here. Normally, if you are declaring your variable, because hour here is a variable, you just say int hour, right? Normally, before now, we've been declaring, we just say int minute, double second, right? But the fact that you put an access modifier beside it makes it an instance variable. We call it an instance variable. All right. So we have private int hour, private in minute, private double seconds. Okay, yeah, we have something like instance variable. Attributes are called instance variable because each instance has its own variable as opposed to class variable. All right. Hour, minute, blah blah blah. Now, so what it means to define class is exactly what we have done right now. We have said, okay, this is a class name time, but time cannot exist on its own. It has to have instance variable, it has to have attributes, it has to have object and all of that. So this is instance variable, but that is not the end of it. There's something called constructors. All right, constructors, will I call them shift? Now call them shift or give them any shiftency title because they have I call it self-initializing. Let's put it that way. They are self-initializing. So when you see a constructor, what you will see is that you will only see the access modifier and the name of the class. So for example, you have created class time here. So when you want to identify a constructor or you want to create a constructor, it is going to be public time. It won't be public void time or public static time. No, it's going to be just public time. The access modifier and the name of the class is going to be exactly the name of the class. Time and what? Time. However, not only will it be the name of the class, it is also going to carry the keyword this. All right. See, the keyword static is omitted. Constructor have no return type. The name of the constructor is the same as the name of the class. Those are the things you need to note. So in defining class, there's something called constructor, and this constructor usually use the word keyword this. So instead of saying private int hour, minute and seconds, it will just directly do what? It will just directly pick on the hour, minute and second by saying this dot minute hour, this dot minute, this dot seconds, and give it its value. And then the next to consider in defining classes is what? The main method. We have talked about the main method severally. The main method has the what? Main, right? As the what? Public. We have talked about void. It's a method that does not have a return type. And you have been seeing static by now. We have seen static several times. Like this static means this method does not change easily. This is a method. It's not flexible. So you call it static, and a lot of methods are static though. Yeah, a lot of methods are static. So because it has nothing to do with the variable, it has nothing to do with the return type. So it's just there. So we have, let's continue. You already recognize the main method. And now, look at this next line. We have time equals to new time. By now, you know what the new keyword is doing, right? So what we are trying to do here now is to instantiate the class time. We are instantiating the class time that we have here at the beginning. We are trying to instantiate it within the main class. We are saying time, you can call this one anything, any object name. So you have time, this equals to new time. By the time it gets to this level, we are trying to say now that time is not just a class, it is what? An object. Time is not just a class, it is an object. When you use new, Java creates the object and invokes your constructor to initialize the instance variables. When the constructor is done, new returns a reference to the new object. In this example, the reference gets assigned. So look at this now. We have time, we have hour, minute, second, and for hour, minute, second, there is what's the name? There's an assignment or values to read. Yeah, memory diagram of time object. Okay, so we have something like this here. This is a constructor. Stack Overflow error. This is a constructor, right? This is a constructor. The reason you have a Stack Overflow is because you are probably, yeah, probably, what did they put there? Doing so causes infinite, yeah, infinite recursion. You invoke anyway, you cannot use new inside of the constructor. You just have to use this dot hour, this dot minute, this dot second. Yeah. So just like we said the other time, this is your perfect constructor. Okay. Now talking about constructor again, we have said that number one, they are self-initializing, they carry the same name as the class, they use the keyword this, there is no static in when you are defining it. And what else? Now, the other thing is that they take in parameters. Okay, so this is an example of a construction that takes in what? Eh, Three parameters. And these three parameters are its attributes. All right. Now, attribute hour, minutes, and seconds. And you have the this keyword getting equal to what? Hour, minute, and what? Second. So if you're a constructor, you have to provide arguments in the new keyword. Something. Okay. Now look at it. They have combined all of the things we have been explaining since it has been combined into one. And the first one is the class, which is time. This is our what? Instance variable. This is our what? This is our constructor. And this is also a constructor, except that this constructor takes in what? Takes in parameters. And what are the parameters? It's hour, it's minutes, in second, right? The second constructor declares parameter hour, minute, and second. All right. So Java allows you to declare parameters and local variables in the same names as instance variable. They don't have to use the same names, but it is common practice. Okay, so that is what we mean by what defining classes, but that is not all. In defining classes, there's also something called what? Getters and setters. Getters and setters. So getters allows you to be able to access the attributes, and setters allows you to be able to set the attributes. So how do you write that? An example is this: public int get hour, public int gets minutes, public double gets seconds. And when you want to set it, you say public void set hour, set minute, set second. Notice that the set and the get are what? Written in small, and then there is what? We call this camel case, right? Okay, so we have something like this. So this is how you write it. And when you write it, you have a return for get. So because get is trying to get to, from the keyword get, is trying to retrieve the values, to retrieve the attributes, you will have a return what keyword. So we have the return this dot hour, return this dot minute, return this, which does not exist in the set. It does not exist in set because in set you are only setting values, you are assigning values to your variables. To your variables, you are assigning values and you are just setting values and all of that. So you don't get to see return. So it's your get that's going to retrieve all those values for you. Okay, so they are very simple. You just need to get. And in test, in writing test cases, most time, we make use of some of this, right? Especially um, when you are focused on some kind of test-driven development. Some kind of test-driven development. Sometimes you are focused on making use of getters and setters. They can be annoying at some point, but they are still very much okay. They are simple to write and simple to understand. So yeah, displaying that is getters and setters. All right. So we also have something called displaying values. We have talked about, yeah. Okay, so you have come across writing other methods, right? An example of other method is this. You have static void print time here. It is not a main method, it is just some other methods, right? So it has a void, it has a method name, and of course static and public, right? So I will call it other methods. So we have this method here that takes in time t, right? Takes in just one parameter. And you have a print statement here that does what? That is calling the attribute of hour on t. Okay. So time t is assumably the same time that we defined here, class time. All right. So within class time, is it? So within class time, we have a method here that is what's called print time, that is taking this time and then giving it a t, right? And saying that this t as attribute hour, as attribute minute, as attribute seconds, right? So let's see an example. Let's try to write something and then we can call it a day. Let's write something in our IntelliJ. Okay. Mm. Example, let's look at this displaying object again. And we can say array control object. Okay, I've written something in object. I will call it time. New Java class time. Okay, so in this new Java class time, I will follow what we have said. So we have the class name, right? We want to write a constructor. So how do we say you write a constructor? You have your public and your time, right? Time. And then that is followed by your this. So we have this. Okay. So let me just say this hour, this minute, this second. And we also said that you have to declare your instance variable. So we have yeah, you can call it private int hour, private int minute, private int second. Okay, so this is your instance variable, this is your constructor. All right, now the next thing is you want to write the main method. Before a main method, yeah, let's write a main method. And so you want to write a main method. Okay, wait, before we write the main method, let's do this one with the constructor with with attributes. This is also cool. Then I will now write a main method and call and say public static void main. No, this is not what I'm doing. I'm not even trying to do anything within here. Okay, so I have a main method. Then I want to talk about setters and getters. Exactly, this thing gets what I'm trying to do. So I have a getter. So this is how you write your getter. So get hour, get minute, get seconds, right? Public get minute, get seconds, right? And then we have done all of that. So the next thing should be your setters. Hmm? Your setters will take in each of those variable in hour, in minute, in seconds, and it will be set hour, set minute, set seconds. Okay. And not set time, set second. Okay, we are done with set. Okay, so we have talked about this. Now the next thing I wanted to talk about is displaying of objects. So we'll create another method called print time, and then okay, public. So that method is public static void print time. Oh, wonderful. Print time. Now, print time takes in type T. By the way, if you are wondering why this intelligence is intelligent, I've been wondering why nobody is asking yet. Is it because it is intelligent? Is that why it is intelligent?
I wanted to ask you, maybe because you've written too many codes now. That's why it has all these suggestions for you.
You think so? You think that is why? Of course, though, the more you write, the more you get something like this. But there are plugins you also install that,
Installed.
that give all of these suggestions too. Apart from plugins, there are also what will I call it now? AI. What will I call it? AI.
Exactly.
Um,
Applications or
applications
plugins.
that
Yeah.
that if you sign up for, and you can actually add them to your IDEs, whichever IDE you are using, and then they will replicate whatever you have done before, that you have ever done before on your IntelliJ. It's going to reproduce it for you each time it sees anything related to it. It will reproduce it for you, and then not only will it reproduce anything you have done before, it's also going to attempt to bring other information from other internet sources for you. So those suggestions you're seeing, some of them are some of the codes I've written before in some other classes. So he's tried to replicate it and bring it out for me. And some of them are sources from internet, that it's just added one or two or three together and then suggested. Sometimes the suggestions are good, sometimes they are not. Depends on
Mm-hmm.
what you want to really accomplish. So yeah, it makes you, instead of writing, it just makes your work faster. Instead of typing and typing, you just enter and all of that. So yeah, it's a good it's good. How do I always ask people to use IntelliJ? IntelliJ itself also has a lot of other plugins. Trust me that you might not even need all this AI things for. Okay, so we are in print time, and we have some system out of print things here. So print t dot time. In fact, see, the suggestion is given is not even the same as. Anyway, let me bring out what I want. I have. I don't know if it is the same as this one. Okay. Let's assume that this is also good. Okay, so look at this now. I want to print time. Do I really have values for them? 000 is what I have for them. So let's see. I have print line t dot get hour, t dot get minute, t dot get second. So what exactly is t, right? Um, mm, okay, yeah, it's already here. T is time t. All right, this t is referring to the class time here already. So yeah, you already know what he is. So we're now trying to get the attribute of time here, that is get hour. And what is our get hour? Let's look for our get hour. Our get hour says that get the value of hour from this. And what is this? 0. Okay. So it's going to get this value. It's going to get this 0 and put colon and get this 0 and put colon and get this 0. The same thing goes for here. T dot hour. If you want to get it directly without going through these methods, because these are methods, our get hour, our get minute, our get seconds. If you want to get them directly, you just call this attribute directly from your class and you will get them. You get the hour. This one is just a print. This one is the minute value and then the second value, right? So if you execute this code right now, nothing will get printed. You know why? The reason is because this method is useless as it is if it is not called within the main class. Or you doubt that? Okay, let's see. So you say you have nothing here. The reason is because it is useless as it is without you calling it in the main class. So what do we do? Because it is void, of course, now. There's no return type. So what you do is now you now go into your main method here. We have one main method here. And then you call print type. So what is print type? So print time is what? Print time takes in time t. So we have print time as what? Time t representing hour, minute, and what? And seconds. As it should be. Hour, minutes, and what? And seconds. There is another way you can also call this time t. Uh uh okay. So you can also say print time. Instead of new time, you just say maybe 12, comma 0, comma maybe sorry. Not no. The- create a print time in time. Of course, we have print time in time. Okay, as private static void. No, that will not fly. That will not fly. So we can't use that here because of the way we have declared, because of the way we have written this method. We have written this method in such a way that it can only be called this way. Okay, now let's see. Let's see what we actually be printed. What should be printed, assumably, should be everywhere you see hour, it should be 11. Everywhere you see minute, it should be 59. And everywhere you see second, it should be 59. It means that when you say get hour, get minute, get second, that's what you should print. Then hour, minute, second, you should print the exact values that you have put in here. Because ordinarily we have 0 here, and this constructor is definitely useless as it is. So this is the constructor that we are making use of now. So we have int hour, int minute, int seconds, having one usage. So this one usage, we are looking at usage in IntelliJ. If you click on it, it will take you to the method that is making use of that method. So there is a main method making use of this method, this constructor method time. All right. So you can see it here that it is looking at exactly like its format. It's taking in parameter hour, minute, seconds, and then by the time you are calling it print time instead of main time, it's also taking in hour, minute, and seconds, right? So if I execute this now, yes, I will have 11 as my hour, my minutes, and my second. And then if I print, okay, this was a print, not print line. That's exactly why it fell on the same line. I thought it was going to fell on different lines so that you see how. Hey, so we have something like this. Let's execute this again. So you see, this one as what? Get really get second is what? Is 11:59:59. And then we have this one 11, which represents the second print statement. And then we have the column, which represents the words, this column here. And then there's another 59, and so on. So the values for hour, minutes, and seconds is the ones we have here, and that is what we get printed when this print time is called. So you see how you call methods, how you call other methods within your main method. Okay, so that's how you display objects. All right, I think we have touched the most important ones here. The equal method, which one is that? Okay, so we have touched the most important things here, and if you are to do any exercise, you can go through exercise 4. Exercise 4 seems interesting. So try to see what you can how you can play around with this exercise 4. I mean, you can touch other areas too. You can decide to even do all of the exercises, please. But this exercise 4, try not to jump it, try to practice with it. Next week, with this, we have come to the end of this class.